Okay, now that we know the molar volume of a gas, let's see about some applications of that information. Okay, so just remember, at standard temperature and pressure, the volume of 1 mole of a substance is 22.4 liters. Okay, so technically this is most true at standard temperature and pressure, but it's for our purposes, we'll just use this regardless of the temperature. Okay, so every kind of gas has this exact same molar volume. So mass or size of the element doesn't change the volume here, and that's because it's a gas. It's not restricted by the size of the individual particles. What it's restricted by is the space it can take up. Okay, and gases can move about and take up the same amount of space regardless of their molecular size. So, your key relationships around the mole. What I like to call this is mole island, okay? Because everything focuses around the mole. Mole island. If you know moles of something, from there you can figure out the liters of a gas. You can figure out how many atoms or molecules you have, or you can figure out the mass of it using molar mass. Okay? So all of this can be done through dimensional analysis, knowing that 1 mole is equal to all of these things in the center, or like in between the places. Okay, so if you need to go from moles to grams, you use your molar mass and 1 mole in dimensional analysis. If you're going from liters to moles, you use the molar volume in 1 mole. Okay, or if another thing this visualizes is there any direct connection between, say, grams and liters, or grams and atoms? You should be saying no. If you need to convert from, say, grams of something to grams of hydrogen gas to volume of hydrogen gas, you will first have to convert to moles. Okay, something else to keep in mind is the process to get off of mole island versus onto mole island. There is a pattern to it. If you think about setting up your dimensional analysis to go 2 liters, okay, so you're in moles, so it's moles on the outside, you put moles, 1 mole in the bottom, and 22.4 liters on top, you multiply. To get back onto mole island, going the other way from liters, you're going to put your 22.4 liters on the bottom, 1 mole on the top, you divide. Okay? This pattern holds true for all of the other directions too. If you're going from mole to atoms or molecules, 1 mole goes on the bottom, Avogadro's number goes up top. Okay? And likewise, if you're going the other direction, it's going to be 1 mole on top and Avogadro's number on the bottom. And the pattern holds true for your molar mass as well. Okay? I always set up the dimensional analysis because that makes it's easy for me to remember to cancel out my units. But you can sit there and memorize that to get off of mole island, you multiply, and to get onto mole island, you divide. Okay? So, now that we know about molar volume, there is an extension to Dalton's law of partial pressures. So far we dealt with, if you're given pressures or given percentages, you can use that to find the individual pieces. But because molar volume is the same regardless of the kind of gas, that you can use the moles of gas in order to actually help you find percentages. So what that looks like. Okay, so if you know your number of moles of each gas, you can find the percentage of your individual gases and then multiply that by your total pressure. So you actually might be able to have less information and still be able to find out some more. So what that looks like is your P pressure of X. Okay, X is the gas in question, what you want to find out. Okay, P total is still your total pressure. The lowercase n stands for mole. Okay, So to find the percentage of gas X, you need to know the moles of gas X and your total moles. And that gives you your percentage. Okay, so NX is moles of the gas in question. And then N total is total moles of all gases. Okay, so let's see a problem like this. So U of the gas is measured at 45.8 pounds per inches squared. The gas is made up of 4.0 moles of oxygen and 32 liters of nitrogen. What is the partial pressure of the nitrogen gas? So I don't have any information about the pressures of my two gases, but I do have enough information to know the moles of both. Okay, one, oxygen's given to me. I know I have 4 moles of oxygen, but nitrogen I am given a volume, which I now know how to convert to moles. So if it's 32 liters of nitrogen, there's 22.4 liters of nitrogen in 1 mole. Nitrogen would be diatomic. Nitrogen, again, doesn't matter. Diatomic only affects your molar mass. And that ends up giving me, when I round 4 sig figs, 1.4 moles of nitrogen gas. Okay, which means now I know how many moles of nitrogen gas I have. I know how many moles of oxygen gas I have. I can combine those to get my total. So 1.4 plus 4 equals a 5.4 mole total. And then to figure out my percentage of nitrogen gas, I would do, so here's where I'm doing this. The px equals pt nx over nt. Okay, so my total pressure is 45.8. I'm going to multiply that by the 1.4 moles over 5.4 moles. What ends up being kind of like 45.8 times almost 26%. Or that gets me a number like 11.9, but ultimately my 32 liters with 2 sig figs controlled everything, so I have to round that to 12 pounds per inches squared. Okay.